Hey guys, Mr. Martin here, back again, talking today about postulates and diagrams. Alright, we talked about 4 postulates already. They were the ruler postulate, the segment addition postulate, the angle addition postulate, and the protractor postulate. You should have those all in your notes, so when we start off at number 5, you're not confused, because we've already talked about 4 of them already. Okay? First one, postulate 5. Through any 2 points, there exists exactly one line. We've talked about that already. There's no way to be more than one line because the line would go back around and loop through one of those points, and there would be no way that there can be a line that loops back around. So through any 2 points, there exists exactly one line. Number 6. A line contains at least 2 points. That almost sounds like the converse of the one we just said. The first one said if there's 2 points, there's exactly one line. This one says if there is a line, then there's at least 2 points. Okay. Number 7. If 2 lines do intersect, then their intersection is exactly 1 point. We're going to talk about these more in some diagrams, but just get these into your notes for right now. Okay. Number 8, through any 3 non-collinear points, meaning points that are not on the same line, there exists exactly one plane. A plane contains at least 3 non-collinear points. Again, that sounds like 5 and 6 that we just read. First one says if you got 3 points, there's one plane. The other one says if there's one plane, you got at least 3 points. Okay. Number 10, if 2 points lie in a plane, then when you draw the line through those 2 points, that line will also be in the plane. Kind of makes sense. It doesn't all of a sudden leave the plane. And last one, if 2 planes intersect, then their intersection is a line. Okay? We've talked about most of those already. Just get those in your notes. I don't really care if you remember that postulate 8 is through any 3 non-collinear points, there exists exactly one plane, but I do expect you to remember that it takes 3 non-collinear points to make a plane. Okay? I don't care if it's number 8 or number 14 for that matter. Okay? Just don't worry about the number of the postulate. Remember what the postulate says. All right, let's look at some examples using diagrams. Okay, so let's look at how do we identify some postulates illustrated by a diagram. So first postulate that's illustrated by a diagram is this one. So it looks like we've got 2 lines that intersect, and we know if 2 lines intersect, then what must be true? That's right. If 2 lines intersect, then their intersection is exactly 1 point, or they intersect at exactly 1 point. Right? Next diagram. Got 2 planes look like they're intersecting. If 2 planes intersect, then of course they intersect at a line. Now remember, okay, the line goes on forever, just like the planes do. So this line going through here goes on forever, just like the planes go up and down forever, okay, and side to side forever. Those are not segments, those are lines going through the planes, okay? All right, next one. Okay. Let's look at this picture. Okay? And we've got a couple postulates going on in this picture. Okay? First one, plane P consists of at least 3 non-collinear points. In this case, we've got point A, right? Point A, point B, and point C. Those all are on plane P as in Paul. Okay? That same diagram. Let's look at postulate 10. It says points A and B. There's a line going through points A and B, namely line N. Okay. Oops, let's go back to that one. Sorry about that. If we have 2 points on a plane, then the line going through those 2 points, line N in this case, this line right here, is also in plane P. Kind of makes sense. If the 2 points are in the plane, the line must be in the plane. All right, let's move on. All right, so let's talk about what we can assume and what we cannot assume when we're looking at a diagram. Remember, I told you that we can never trust the picture. There are some things, though, that we know are going to be true just by the way they drew the picture. For example, if they draw a plane, okay, this blue quadrilateral here is a plane, namely plane P, you can assume that all of those points are coplanar. They're on the same point. If they wanted there to be non-coplanar points, then they would have drawn you a second plane. So if there's only one plane, you can assume the points are coplanar. Okay? Second thing, based on the way they're drawn, AHB, angle AHB, that's going to be this angle right here, AHB. And the angle BHD, okay, that's going to be this angle right here, BHD. Okay? Because they make a line AD, then they are, of course, a linear pair. Okay? You don't have to be told that they're a linear pair. If they make a straight line, then you can assume they're a linear pair. Okay? Also, angle AHF. That's this angle here, AHF. Okay? And angle BHD. Back to this angle up here. Okay? Those are vertical angles because their sides are opposite rays. Okay? When two lines intersect, they make a pair of vertical angles. So we can say that angles 1 and 2 are vertical angles. And they also make a second pair of vertical angles, which you can see are 3 and 4. So you don't have to be told that those are vertical angles. From the diagram, you can see that they're vertical angles. Okay? All right. Also, on this same picture, you can tell that points A, H, and D are all collinear. A, H, J, and D are all collinear. They lie on that same line. You don't have to be told that they're collinear. Okay? And lastly, lines BD and BF intersect at point H. Okay? They have two lines, BD and BF. Actually, I'm sorry, I think that's supposed to be AD. Let me fix that for you. Okay, that's lines AD. Okay? AD, line right here, and BF. Those intersect, of course, at point H. Okay? So line AD and BF intersect. You don't have to be told that their intersection is at point H. There are things that you can interpret from the diagram. Okay? Let's talk about things that we cannot interpret from the diagram. There's a difference here. Okay? We cannot assume things that are not connected through a line or by a line. For example, G, H, G, F, and E are not collinear. We cannot assume that they are collinear because there is not a line drawn through them. If there was a line drawn through them, like on the previous one with A, H, J, and D, we could assume they're collinear. All right? We cannot assume that lines BF and CE intersect. Okay? Just because they are drawn there and they look like they might intersect, we cannot assume they'll intersect. Okay? Likewise, we cannot assume that they do not intersect. If they were parallel, they would tell us that line BF was parallel. That's the symbol for parallel. Okay? Line CE. If they were parallel, they would tell us they're parallel. Okay? Don't assume from the picture that they are or aren't unless they're drawn with an intersection like AD and BF were on the previous example. Okay? Couple more. We cannot assume that BHA, angle BHA, we cannot assume, okay, that angle BHA is congruent to angle CJA. Just because they look congruent, we cannot assume it. If they want them to be congruent, they'd either put an arc, one arc in both, or they would tell us those two angles are congruent. Do not assume angles are congruent unless you're told so. Okay? Line AD is perpendicular. Again, this is the sign for perpendicular. Do not assume that two lines are perpendicular. Let me spell that right. How about perpendicular? Okay? Don't assume they're perpendicular unless you're told. Again, they will tell you AD, line AD is perpendicular to line BF. They want you to know they're perpendicular. They'll tell you they're perpendicular, or they will put a little box in the corner telling you that they make a right angle. That brings us to the last one. AHB, angle AHB is not 90 degrees, because if it was, they would have told us either that those two lines were perpendicular, or they would have put the box right there. Since they didn't put the box, you can assume those are not perpendicular. Okay? So like I said before, don't trust the picture, don't trust the picture, don't trust the picture. There are some things you can assume, like if the points are on a line, they're not going to trick you and go, haha, that one's not on a line. Okay? You can assume they're collinear if there's a line drawn through them. Okay? You can assume that they're coplanar if there's only one plane drawn, but you cannot assume things like angles being congruent or lines being parallel. You have to be told those things are parallel. So as we work through proofs, they will tell you through the given information what they want you to know. All right, that's a lot of information again. We will continue to work on proofs on Monday, but I just wanted to give you some more postulates and clarify what I meant by don't trust the picture. All right, we'll see you guys in class on Monday. I hope you have a great weekend and come ready to rock and roll on the rest of those proofs. We'll talk to you later.